So let's start with robot show and tell. Can I see a show of hands, people that want to show robots? Okay. So I will be wandering around trying to grab people. You're not going to show that robot? That's a cool looking robot. Okay, we'll start with Marcus. You have a pocket?
Yeah.
Okay, shove that in your pocket. Very good.
This is my shield bot I got from the Maker Faire in a booth. We just, since my dad accidentally fried the Arduino it came with, we set up a Arduino Uno with it, and so ShieldBot doesn't really work yet. All it will really do is sort of spaz out around on the table until it nearly falls off.
No.
That's really all it does.
Very good. Dave?
Test 1, 2. Hola. All right, so my robot doesn't quite do as much as the last one did. Still under construction. I just wanted to show this little wheel, which I think is kind of cool. It just became available recently. It's called the Hub-E, Hub-EE, and SparkFun has it, and I think somebody else has it. And other than this pink 3D printed stuff, basically you can see the wheel is just a puck. But what's cool about it is it has the motor driver electronics in it, and an encoder in it, and the gear motor in it. So basically, if you have an Arduino or something like that, basically all you need to do is, wiggle the TTL signals to drive the motor controller, and you get quadrature encoder outputs back. So 2 screws, slap it onto something, drive it with an Arduino, and you've got a robot. So anyway, all I need to do now is build the rest of the robot around this. But actually, I've got a couple of robots under construction in this. I just thought some people would be interested in hearing about the Hub-E. Yes, you have something you want to say?
It's working. Its working name is Musepetre, which is Norwegian for moss on a tree, because it doesn't really move yet.
Very good.
Good enough for government work.
Yes. Okay, let's roll in our next robot. Who's going to be next on the robot show and tell? You? No? You ready, Bill? Oh, well, don't worry about it. Can you hear me? Osmond. Can you hear me? How's that? Hi, I'm Steve. This is my Robo Magellan entry. For those of you not familiar with it, it uses autonomous navigation to go around a course with predefined cones. The objective is to go to the cone and touch it, and then back off to the next cone in the shortest amount of time. A couple features it uses is GPS to figure out where it is, and it has a compass here on top. It knows its current location, knows where the waypoint or the cone is, and does a calculation, determines the direction and distance, and it continues until it gets to that point. Let's see, other things going in. This is a Traxxas car, which is very handy. Spend a couple $100 and get something that runs pretty fast, pretty reliably. And it uses a parallax propeller for controlling. What else? It's got a video system, and coupled with a tablet. A tablet runs RoboRealm, so it tells where the location. You put in filters by color and by size, and it can tell where a cone is and direct it to the cone. And it comes and touches the cone, and then it backs off and goes on to the next cone. Let's see. And it has a solid-state drive. Thought that was pretty handy. In my debug process, there was crash after crash, and I download the data, and then evaluate what happened with the device. Let's see. So I used ping sensors as obstacle detection, and I made the famous last mistake, which was adding 3 extra lines of code the night before a competition, and didn't quite work out as I would like. So it ended up going around in circles, and I pulled out those lines, and it went off reasonably well the second time around. The ping sensors, they work one at a time. They take about 150 milliseconds to get a signal. And in a half a second, if you're traveling 10, 15 miles an hour, a lot can happen. For next year, I'm planning to upgrade to a Max Robotics sensor, which they work on I-squared C-bus, where you can send out one signal, you can make all the readings at once, and then you can immediately take the reading back, or wait a half a second after making a compass reading or something else. So hopefully that'll help it out a little bit next year.
Any questions?
One question.
Yeah, so what's that chassis? Is that a...
This is a Traxxas, the TRAXXAS, they have a website. I think mine's an Emax. So I think they're about $400 or $500.
Okay, and what was that kind of sensor again?
This is a Max Robotics.
Max Robotics?
Max Robotics, yeah. And also, yeah, one other feature, this comes with a remote control that, because it needs to be autonomous, you can't sit there and say left, right, stop. But I can turn it on and off. You need a kill switch feature in case it's getting ready to run into somebody at 20 miles an hour. So I was able to use the existing wireless just for stop button, document preview.
Any other questions? Thank you very much. I'll just comment, these sonars we get on eBay, and you buy them in quantity 10, they're $1.64 each. Okay, so we used to spend like $30 each, and now we buy them in quantity 10, and it's less than the cost of one of those Max Robotics ones used to cost. So, great on. Let's see, I think Brian's next. Ready, Brian?
I can probably put this up on the table once I get up here.
You want it on the table? Let's go for it.
Let me turn it off. No, let me shut it off first.
You can shut it.
All right. This is my latest version of my never-ending quest for a robot guide for the blind. I continue looking for something that I can give demos at different locations, in different places where people are interested in this type of thing. This is the latest Brookstone rover, which can be controlled by an iPhone, and you can make it go forward. I have a ultrasonic sensor, a mini guide on top right now that'll is a ping sensor, ultrasonic, and so it'll beep. I got a speaker on top of here along with my harness, so this will actually guide, and if it sees something in the path, the user is the chooser of the path, but this will detect anything in the way and use an ultrasonic sensor. I've actually got a couple of grants out where I want a couple engineering students to actually tie in 2 sensors to this so that the user can make this go forward, and then the sensors will control how the robot goes. But right now, this is just sort of a quick demo unit. And I also have another unit that's a NITO unit that I'm working and doing some other things, or a couple different organizations are helping with this. So this is my latest demo unit where I can give sort of a visual of how this works.
Any questions? How many people were here? It was about a year ago?
Yes.
About a year ago, it was talk. Look at how much progress is made. So, very good. Okay, Gertz, I think you're next.
So, yesterday I realized that I need to show something, so I found this robotics remote controller from Mike's Vanadium Labs. So I decided to hook it up and try. So what it is a Arduino board with some additional components and mainly joysticks and buttons. And there is an XP transceiver here, and we have another XP transceiver connected to a USB port inside the robot. So let's see what it does. I didn't have much time to test it, so I don't really trust it. So what's here? Let's see if it does something. Yeah, it actually works. So what this controller does is it sends a packet containing all the readings from joysticks and bits from buttons. So I'm reading those packets from a serial on the other side and converting into cross messages to drive the robot around. Yeah, I can, but I don't trust it. It can run away. It is not a table, but
I'll put this down and I'll be the catcher, okay?
well, maybe we can at least turn it. That's not so dangerous. Oh, I think that was it. Okay, thanks.
Lots of progress there. Okay, are we good, Bill? Okay, let's go. Bill Benson and I have been working on this robot for quite a while. This has a Raspberry Pi. Does everybody know what a Raspberry Pi is? Okay, I'm seeing a lot of heads not up and down. And it's got a Wi-Fi dongle here with a pretty good antenna. So we move around. And so what's actually interesting about this robot is that we're running Python on the robot, and we're talking to it wirelessly with Bill's laptop back over there. The other thing you'll notice, some people have been putting access points on their robots. This one, the access point is actually remote from the robot. And then the last thing is, most people have heard of Adafruit, which is a New York company that builds stuff and sells it. They've come up with something called Web IDE, and that is running on this robot. So we're actually programming in Python wirelessly connected to the laptop there. So I'm gonna put this on the ground because it's not a table bot. And it's probably gonna crash because that's what always happens. But the wheels, we're turning there.
Okay, now?
Yeah, go for it. It's not running. Oh, there it goes. It's doing something. Okay, see what happens. Run it again if you can. Hit run. There you go. Yeah, it did move. So, sorry. This one is actually safe enough that I'm willing to put it up on the table and catch it so that people can see. So give it a run.
Here, I'll catch it.
No, I'll catch it. There we go. And then it's going to turn. That's the program. It goes forward and turn. That's all it's doing right now. But basically what I'm trying to do is get a low-cost Python platform for people who want to program their robots in Python. And so we've got this one pretty inexpensive right now. So that's what it's all about. Okay. Yeah.
So do you have What about the power requirements with the Raspberry Pi and the wireless thing?
You know, the Raspberry Pi doesn't need up that much power. I mean, we're using a pretty beefy RC battery pack here, and we've run the battery down, but it takes a while. So, you know, no real problems there. That's one of the nice things about the Raspberry Pi is it's not too power hungry. And there's things you can do to the Raspberry Pi to get the power down. You can desolder all the LEDs and a few things like that. Yes, Marcus?
How much would it cost?
You know, that's a hard one for me to answer because that robot's got some old stuff that you probably couldn't buy anymore. But the Raspberry Pi proper is about $35.
No, I mean the Python.
Well, Python's free. So it's absolutely free. The reason why I'm interested in Python is not because I think it's the world's greatest language, but it is the language that most people are first exposed to when they go up there to take their introductory college program course. I mean, to date me, they taught Fortran when I went to school. We did it on punch cards, so I'm a little dated there. But, and then it became Pascal, and then I don't know what it is, but these days it's Python. And so I wanted to, I've been interested in getting a robot that people could program in Python, because that's what's taught. Do you have a question? No. Yes?
Yeah,
So you're serious? Come on up. Are there any more robots to be shown? You, anybody else? And then you, okay. So it's going to be, I've forgotten your name here. What's your name again? What?
Sinead.
Sinead, and then you. Okay.
Okay. Not much to show yet. This is the first robot I built. It's my second time here. And I'm not a hardware guy, I'm a software guy. So the cool thing that I like about this robot is it learned how to stand on its own. It's all neural net based. And I started with just 3 servos because I thought that's the minimum amount you need to get something to walk. As it turns out, you need at least 2 more. So let me plug it in. There's no IMU, so it won't balance. Okay, I need to adjust its feet. But it learned by itself how to balance on my table, which is probably slanted. And that's pretty much it right now. The next step is I have a simulator that I'm working on, and the neural net is going to learn all the various gaits, walking. I'm not going to program any animations at all. It's going to learn them on its own. That's it.
What kind of feedback did you give it or to make it learn? It must have some kind of sensory input.
The first, because I have IMUs, but I haven't added them to this yet. It's only sensory input were these buttons. It would do something sort of at random at first, and I would push the button and say, that's good, that's not good. And that was the feedback. Ideally, the feedback will come from IMUs once I get those hooked up. So then it will know, did I fall or not? Yes.
So you said that 5 servos are necessary? I only see 3.
Exactly. This one will not walk. It will jitter around, but it can actually make forward progress very easily. I thought it would be able to. I thought it would learn how, but it couldn't. It just can sort of, done with feet. I call it ghetto bot. You can tell it was made from like molly screws and metal ribbons. So.
How do you implement the neural net? Is that a controller or some sort?
I'm sorry?
How do you implement the neural net?
Oh, it's my own code. It's all C++ code that I've written for other projects.
What control system does this use?
There is no control system. It's a standard C code that I ported over. I have a robot that's based on a Pi, but this one is just using a simple Arduino. So I just ported it over to Arduino code.
So it's just an Arduino running the neural net?
Yes.
Okay.
which is why I wanted to minimize the number of servos.
Any other questions?
Any other questions? Yes.
Are you using a simulator package to do your simulation or just SQL?
No, I have an old sim. I used to do video games, so I have a lot of old DirectX and Direct 3D code, and so I'm just writing my own simulator based off old video game code. Yes.
How many nodes and layers in your network?
Right now, just 2.
2 layers?
2 layer.
2 nodes?
No, it starts off with 512, and then it finds out it goes down from there as it eliminates nodes. But then once it settles on, once it's found a solution, it will strengthen the nodes that are left over.
Okay,
That's it. Thanks.
so
Okay, hi, I'm Sharon Marzuk, and I wanted to show this little educational robot. He's called Thymio, and how it works is you just hold that down, and he has some pre-programmed modes. So in this mode, he would follow whatever he sees. He has about 20 sensors from proximity sensors. What's really cool is you actually see the interactivity. And he also has this one where he'll go and he'll turn around whenever he sees something in front of him. It's called like curious mode or explore mode. Over here, he's afraid of whatever he sees, and you can make him make noises. And also you have an accelerometer, so you can make him respond by that. He also has a temperature sensor, so you could put him in the freezer and he turns blue when he's cold. And you can actually record your voice, say, "Help, I'm in the freezer, let me out of here." And also he has an IR sensor, so you can actually make him respond by remote control. And he also has these 5 touch sensors, these 2 sensors at the bottom, which helps him detect edges, so that way he in a second, but he wouldn't fall off the edge because you would actually see it. And the really cool thing is there's a drag and drop programming language that if this happens, you do this, and real code gets compiled real time. So it lets you understand real code, and then you can modify real code, and then you can actually start to type real code. Thymio was developed out of EPFL, which is a lab in Switzerland. And I have a company in the US called techiekids.com where I'm having a summer camp this summer. I'm a full-time teacher at Woodland School in Portola Valley, where I'm teaching with this robot from kids from kindergarten through 8th grade. And the kids are doing projects, creating animals from it, different inventions, and using their creativity. So it's a pretty cool platform, and it grows with you, and there are also ways to build Lego off of it as well. So, thank you.
very good. How much?
It's on sale at my website for $189.
$189. Okay.
Thank you.
Yes? Yeah, he's going to add a couple other things.
So I was going to demo. I was going to demo the exact same robot, and I want to mention the reason I got it was because it's got the programming interface that Sharon just showed. You really have to see it on the computer. It's very similar in some respects to Scratch or 12 blocks, which I don't know if Hannah is going to show tonight, but it actually is very simplified in that. The reason I got this robot instead of going to something that uses Scratch was because I've got a 3-year-old. He's just learning to read. He's getting really good at reading, but I didn't want to bother with the language on top of the visual. So my 3-year-old is actually taking this robot. I got it a couple of weeks ago. he sat down and within half an hour he said, I want the robot to make a sound if I press this button, I want the robot to go backwards if I press that button, I want the robot to stop if he sees this something on the sensor. It's got a series of actions, a series of events, and you can tie them together, and my 3-year-old programmed the robot. So it's a very cool platform for very, very young kids. And then on the website, I know on Sharon's Techie Kids website, they've got some cool demos and displays and videos, as well as on the Asiba wiki. They have some really cool videos of things people have done with the robot in terms of hooking it up to Lego to use it as a garage door opener, to make some really creative things. And I'll actually probably turn it into a table bot and run the table bot challenge the next couple of months. So it's an interesting platform.
Very good.
We had a wonderful time at Maker Faire this past weekend. Sent some links out earlier. One of my favorites was the Wallow Teddy Ruxpins, and this fella had an art project where he had 80 Teddy Ruxpins on a wall, and he would have them speak various emotive social media. As it came up, it would shine a light on each bear as it spoke. I am happy, I'm sad, I'm going to kill myself or whatever. And the light would shine on that particular bear. Anyways, I told him I was with the home group. He was actually he had a cluster of 16 bears there. And I told him I was with the home group club, and he said, well, heck, we'll give you one of these things. You got a microphone? You got a live mic there? I don't know if it's going to talk? Sorry. He's a very rude bear anyways. Let's see here. I think he said enough already. My eyes aren't let's see here. There it is. Anyways, so he's basically the Teddy Ruxpin originally was designed with a tape, and it told stories and so forth, and he's hacked it for the Arduino, and he's got circuitry in there, so you just treat it like a servo, to open and close the mouth. And I've added the Napoleon Dynamite-isms. Anyways, that was one of the interesting things there. Oh, there was so much. Hey, so next month is our 11th annual HBRC Challenge. This is the meeting of where the whole meeting is show and tell. And so you'll definitely want to, let me say it this way, I'm going to be really, there it is. I'm really going to be hounding everybody to build robots for next month's meeting. We're the Homebrew Robotics Club. That is to say, we brew robots at home. So this isn't like, entertain me tonight kind of thing. We actually build stuff. So I want everybody to bring the stuff that you are building. And if you're not building anything, you're really not clear on the concept here, folks. So I'm going to be on you this month, all month long. I'm only going to bring 3 or 4 robots. I'm going to limit myself, okay? So I'm not going to do the filter thing. It's going to be the potluck dinner. We're going to start early at 6 p.m. and extra karma points for robot-themed foods. Again, the whole meeting show and tell. Always feature the tabletop challenge. And now we're all moving into the floorbot challenge. The floorbot challenge, I think, is the big thing now. What is a floorbot, you ask? A floorbot is a robot that's too big for the table. But the 3 phases basically are go from one end of the room to the other and back. Phase 2, locate an object in the room. And phase 3 will be to fetch that object. As always, we'll play these challenges in the month of June, August, and October. And so June, bring what you're working on. I don't care what shape it is, you're bringing it in June, and everybody's participating in this show and tell. The whole meeting is show and tell. If you don't bring anything, you're not participating, okay? So that's all I have to say. Thank you very much. Oh, yes.
So what's an idea for the distances in the floorbot challenge?
Well, let's say I'm standing here. I would go to that end of the room and back. Phase 1.
Without falling off the floor.
Ladies and gentlemen, Wayne Gramley.
Without going through a portal.
Yeah, and don't hurt anybody. That's a basic rule. Or don't damage the environment. Thank you very much.
Okay. So, are we ready, Steve?
I need another 5 minutes.
How much?
I said another few minutes, so if there's another robot.
I think we're out of robots. So what we're going to do is we're going to change the thing. We're going to take a 5-minute break so people can go to the restroom and stuff. And then we're going to come back. And Steve's going to be ready, we hope.
Yeah.
And then we're going to do Hano's talk, okay? So 5-minute break. Go for it.